Hello and welcome to my channel. Today we'll be discussing about the electric field. So before going to the electric field, before starting our discussion, we'll uh, discuss some basic things about the types of charges. So basically we have two basic types of charges. These are positive and negative charges. The charges are the basic properties of matter and basic properties of metals. I will not concentrate my discussion, my lecture uh, on the charges, but we'll be discussing about the electric field. Let's have a quick look at the source charge and the test charge. Source charge is that one which produces the electric field, and the test charge is that one which is used to detect the presence of the electric field. The test charge, which is used to detect the presence of the um, electric field due to a source charge, should be small so that it does not disturb the configuration, so that it does not disturb the electric field of the source charge. Mainly here we will be dealing about the electric field due to point charge. If we talk about the point charge, then we have two types. These are positive and negative point charges. So now we'll define the electric field first. So electric field due to a point charge is the region around the charge in which any other charge experiences a force of attraction or repulsion. That is, you can say the uh, electrostatic force of attraction or repulsion. So for example, we have taken a uh, source charge here which is positive, and this is the region where we can feel the presence of the electric field. We know the like charges repel each other and the unlike charges attract each other. If we bring a point charge here, if we take a test charge here, then it will be repelled by this source charge, because we already know the test charge should be small and positive, because uh, the test charge should not disturb the electric field of the source charge, or you can say the configuration of the source charge. So this is the region where you can feel the presence of the electric field due to this source charge plus Q. The source charge may be positive or negative, but the test charge should always be small and positive, as the reason is already uh, stated. Now if you bring a test charge here in this region, this will be repelled by this source charge. So this is the region where you can feel the presence of the electric field due to the source charge plus Q. Now if you take a source charge to be negative, then it will be the test charge will be attracted by the source charge. Now let's jump to the electric field intensity. So how will you define the electric field intensity? Actually, electric field intensity at a point in an electric field is defined as the electrostatic force experienced by an unit positive test charge placed at that point. It is a measure of the strength of the electric field at a point in the electric field. The strength of the electric field at a point in the electric field is given by this expression, where F is the force experienced by the test charge placed at that point in the electric field, and here the Q naught is the test charge, E is the electric field intensity. As I have already stated that the test charge, which is used to detect the presence of the electric field, should be small and positive, so that it does not affect the distribution, it does not affect the configuration and the electric field due to the source charge. But to be more exact, the ratio of F by Q naught, where Q naught is the test charge, as the magnitude of the test charge is made smaller and smaller, so that it finally tends to zero. That is, the limiting below of limit Q naught tends to zero, F by Q naught defines a vector known as the electric field at the point. The SI unit of electric field intensity is Newton per Coulomb. It is a vector quantity. Let's have a look at this figure. So here I have taken a source charge plus Q and a test charge um, Q naught, which is small and positive, is taken at this point P, which is at a distance of R from the source charge. So here the force experienced by the test charge is given by this expression, and the force is directed along this line.